Hello everyone, I am Mohsena Ashraf and I am going to present our paper DIY Graphics Tab, a cost-effective alternative to graphics tablet for educators, and my other co-authors are Mohammad Imrul Jubair, Arafat Ibn Yusuf, Tashfiq Ahmed, Hassanat Jami and Faisal Reza. First of all, in case of our traditional classroom method, having a whiteboard or blackboard is vital for teaching. Due to the COVID-19 outbreak, most of the countries have shifted to the online teaching method and e-teaching has become inevitable now. It is really essential for a teacher to record lectures, and on different online video platforms, recorded tutorials are becoming very popular. For recording the lecture videos, which is really important for the educators, two of the most common methods used by people are utilizing an overhead camera arrangement or using a graphics tablet or tab to capture the writings. In case of an overhead camera setup, we can see that the lecture is mostly written down on a paper and a recording device, for example, a smartphone is mounted on a dedicated camera stand and we need a bird's eye view of the paper which is photographed from the top. And in case of using a graphics tablet, we know that these graphics tabs are really becoming popular in the current teaching method because it has become a viable alternative to the traditional whiteboard setting. But most of the educators find it difficult to use because they are very expensive and most people cannot afford to buy it. For using a graphics tablet, a user needs to synchronize his hand and eye both, as most general purpose graphics tabs do not include a built-in screen, and users must maintain their gaze on the computer screen while hovering their hands over the tab. Moreover, it needs certain developments to be mastered by the educators or trainers, which can be really difficult. The uses of an overhead camera or a graphics tablet by an educator is determined mostly by the three factors, which is cost, quality, and comfort of using. We tried to develop a method blending these two teaching systems. As most people cannot afford to buy a graphics tablet, we worked within a limited budget and we wanted to combine the old-fashioned pen and paper technique with the modern computer-based recording technology as it is more comfortable. Our method do not require previous expertise on hand-eye synchronization, and this system can be considered as a shortcut to record lecture with a laptop, a pen and paper. We call this system Do-It-Yourself Graphics Tab or DIY Graphics Tab in short. For developing the system configuration, we assume that the user possesses a laptop computer and the user wants to record lectures. This figure represents our DIY graphics tab system. The educator needs to place a piece of paper in front of his or her laptop and then tilt the laptop's lid at an angle of around 45 degrees with respect to the base to capture the paper by the webcam. After that, it stores the frames that are created while the user is writing. And our system processes these frames so that just the region of the paper is kept. The extraction of the document is carried out regardless of whether or not palms are present over the document during the process of extraction. A non-affine transformation is then applied to the paper in order to experience it from a bird's eye perspective. According to our literature study, most of the previous works have been done on capturing only physical class structures and analyzing its contents. The most relevant work which matches to our system is WPP or Webcam Paper Pen, which has been done in 2014. Our DIY graphics tab minimizes the complexity of the Webcam Paper Pen work. For example, WPP requires additional tasks for calibration and setup. It requires extra camera and extra equipment. It is also required to keep the paper steady while writing in WPP. User needs to specify the type of the pen, it requires eye-hand coordination, and it also has a restriction on handedness. But in case of our system, we do not have any of these constraints. The setup of our system, which I described earlier, captured the input frames. After that, we moved to the paper detection phase. We exploited machine learning approach to detect and extract the paper's region from the input frame. For extracting the region of the paper, we have developed a dataset of 1800 images of papers which has been taken in different positions and light conditions and has been occluded by palms and pens. We labeled all the images of our dataset by selecting the corners of the paper, even with the region which was obscured by the palms of the user's hands. The coordinates of the corners of the paper are ordered to generate the convex hull of the quadrilateral mask covering the paper area. For the paper segmentation, we used mask RCNN and extracted the largest contour to obtain the corners. Due to the fact that the frame was recorded at an angle, the segmented paper had perspective distortion. For performing a bird's eye transformation onto it, we employed 4-point perspective transformation, which we can call inverse perspective mapping. The wrapped image is then scaled with appropriate scaling factor based on the paper size. In our last stage, for removing palms and fingers portions and to remove noises, we employ adaptive thresholding. After that, we apply morphological operations such as zeroation, dilation, and opening closing, and then the connected component analysis for hand and noise removal. Our system is also built to facilitate those who are left-handed. Initially, the user must specify if he or she is left or right-handed. For the right-handed people, the system doesn't require any change. But for the left-handed people, our system first flips the input frame along y-axis and performs segmentation. After that, it is flipped again along y-axis and then inverse perspective mapping and other processings are done. For the experimental setup, we conducted our machine learning part on a machine of AMD Ryzen 8 core processor with 16 GB RAM and a GPU of NVIDIA GeForce GTX 1060 6 GB. Our training of master CNN took 60 epochs with a loss of 0.086 and a cross-validation loss of around 0.37. Here we can see the qualitative results of our system. The top row represents the input frames from the webcam. The next row shows segmented and perspective transformed paper vision. And the bottom row represents the processed outputs. This slide represents a demo of our DIY graphics tab. This slide represents the correctness of handling the left-handedness in our system. The average root mean square error of our system is 0.091, which has been measured on 820 cases. Here, F0 is the user's writing captured using an overhead camera, and FD is the output of our system for the same writing. We performed the user experience evaluation with 29 teachers from the university level who were invited to record their lectures using our DIY graphics tablet. We divided the teachers into 3 groups. The first group consists of the people with few technical background except for experience of using laptops, and they were mainly from the arts and commerce disciplines. The second group consists of the educators with technical background but who has no previous experience of using a graphics tab. And the last group consists of the people with technical background who has previous experience of using a graphics tab. The instructors utilized our method and graded it according to Likert rating method on a scale of 1 to 5. This graph illustrates that no teacher marked our system very poor, whereas almost 59% teachers rated our system excellent. 3 groups of teachers' ratings are demonstrated. We can see that no teacher from any of the group rated our system very poor, whereas 30 to 80% teachers marked our DIY graphics tablet as excellent. We also performed the study with 49 students from the university level. We were asked to watch a recorded lecture made by DIY graphics tab and to score the quality. Here we can see that no student rated our system 1 star, whereas almost 50% students rated our system 4 stars and almost 30% students rated our system 5 stars. We also performed a questionnaire with the instructors, and most of them agreed that our system replaces the graphics tab perfectly and it is a better cost-effective alternative for the graphics tablets. We were also concerned that if the tilting of the lid will be an issue for the instructors, but almost 73% of the educators stated that it is totally okay for them. However, we still have some limitations in the current version of our system. It is not fully suitable for real-time processing. It works from recording lectures for future uploads. Flickering can occur in some cases. Moreover, writings that are located at a long distance from the camera can produce hazy outputs. Also, the contents obscured by the palms are not retrievable for some frames. In future, we plan to solve the earlier mentioned limitations. We want to enrich our dataset with diverse backgrounds and different lighting conditions. We also want to use more advanced instance segmentation techniques while introducing some gesture recognition to add new features. We plan to optimize the implementation to work smoothly in real time. Thank you for listening to my presentation with patience.